Imagine a blast so powerful it outshines an entire galaxy. That's the reality of a supernova. Supernovas are not just any ordinary cosmic event, they are the extraordinary death throes of stars. They are the grand finale, the last hurrah of a star's life cycle. But what exactly is a supernova? In the simplest terms, a supernova is the explosion of a star. It's the final stage in the life of a massive star where its nuclear fuel is exhausted and it is no longer supported by the release of nuclear energy. The star collapses under its own gravity, resulting in a shock wave that causes the outer part of the star to explode. Now, when we say explosion, we're not talking about a small pop. No, this is an explosion of astronomical proportions. The energy released during a supernova is so immense that it temporarily outshines all the stars in its galaxy. Imagine that for a moment, one single star blazing with such intensity that it outshines billions of other stars. But it's not just light that's being unleashed. A supernova is a cosmic generator, producing and dispersing elements across the universe. Everything from the oxygen we breathe to the iron in our blood, all these were once cooked up in the heart of a star and then scattered across the cosmos by supernovas. The energy of a supernova is so powerful that it can trigger the birth of new stars, creating a cycle of stellar life and death. It's a cosmic dance of creation and destruction, with supernovas playing a pivotal role. And the spectacle? Well, it's nothing short of breathtaking. If you're lucky enough to see a supernova from Earth, it would be like watching a new star being born in the night sky, a brilliant point of light that wasn't there before. So a supernova is not just an explosion, it's the ultimate cosmic fireworks display. It's nature's grandest spectacle, a sign of the incredible forces at play in our universe. But how does a star become a supernova? It's a tale of life, death, and stellar drama. Let's begin by understanding that not all stars are destined to become supernovas. It's a transformation that's reserved for the most massive stars in the cosmos. A star's life cycle is a delicate balance of forces, a cosmic ballet of gravitational collapse and nuclear fusion. In the heart of a star, intense heat and pressure fuse hydrogen atoms together, creating helium. This process, known as nuclear fusion, releases an enormous amount of energy, which pushes outward against the force of gravity, trying to collapse the star. As a star burns through its hydrogen supply, it starts fusing helium into heavier elements like carbon and oxygen. This process continues, with the star creating heavier and heavier elements until it begins to fuse silicon into iron. Iron, however, is the end of the road in this fusion process. It's a stellar dead end. It doesn't release energy when fused, but instead absorbs it. This causes the core of the star to collapse under its own immense gravity. In less than a second, the collapsing core rebounds, sending a shockwave through the outer layers of the star. This shockwave causes the star to explode in a brilliant display of cosmic fireworks, giving birth to a supernova. But remember, not all stars get to go out with such a bang. Only stars with a mass at least 8 times that of our Sun can become supernovas. Smaller stars, like our Sun, end their lives more quietly as white dwarfs. So what determines if a star will become a supernova? It's a combination of its mass and composition. The larger the star and the more heavy elements it contains, the more likely it is to end its life as a supernova. In essence, a supernova is the grand finale of a star's life. It's a spectacular cosmic event that reminds us of the fleeting nature of existence, even for the most colossal objects in the universe. The impact of a supernova goes beyond a spectacular light show. It's a cosmic creator and destroyer. Imagine a cosmic event so powerful that it can both create and obliterate. That's the paradoxical beauty of a supernova. When a star goes supernova, it doesn't just fade away. No, it goes out with a bang, a cataclysmic explosion that sends shockwaves through the universe. Now let's talk about creation. You might be familiar with the phrase, "we are all made of star stuff." This isn't just poetic, it's science. When a supernova explodes, it releases a tremendous amount of energy and matter into space. This includes elements heavier than iron, which can't be formed in the heart of a star. Elements like gold, platinum, and uranium are all products of these stellar explosions. So, that gold ring on your finger, that's supernova material. But supernovas aren't just celestial factories, they're also cosmic demolition crews. The force of a supernova explosion is so immense that it can obliterate nearby celestial bodies. Planets, asteroids, even other stars can be destroyed or sent hurtling off into space. The shock waves can trigger the formation of new stars, leading to a cycle of cosmic life and death. there's more. Supernovas also play a crucial role in the distribution of these elements across the universe. The explosion scatters the stars' enriched guts across space, seeding future generations of stars and planets. Essentially, supernovas are the universe's way of recycling, and if a supernova occurs close enough to a planet with life, it could potentially cause mass extinctions. But don't worry, the chances of that happening are incredibly small, so for now we can appreciate the cosmic spectacle from a safe distance. So what's the takeaway here? Supernovas shape the cosmos. They're cosmic events of creation and destruction contributing to the very fabric of our universe. Supernovas, in their death, give birth to new elements and reshape their cosmic neighborhood. You might be wondering, could a supernova affect Earth? Well, it's a possibility. Now don't start building your underground bunker just yet. A supernova would have to be extraordinarily close to our planet to cause significant harm, and the odds of that happening are extremely low. Let's unpack this a bit more. When a star goes supernova, it releases an immense amount of energy. This energy, in the form of radiation, can cause damage if it reaches Earth. The radiation can potentially deplete the ozone layer, our planet's protective shield against harmful ultraviolet rays from the sun. Without this shield, these rays could reach the surface, causing widespread damage to ecosystems and possibly leading to mass extinction events. But again, let's stress the word potentially. For a supernova to do this, it needs to occur very close to Earth, within a few dozen light years. Now, space is vast, and our nearest star predicted to go supernova, Betelgeuse, is about 600 light years away. That's way beyond the danger zone. Moreover, stars don't just randomly explode, they go supernova at the end of their life cycle, which we can predict with a fair degree of accuracy. Astronomers keep a close eye on stars that are in the late stages of their life cycle, and currently none within the dangerous proximity are at risk of going supernova. So yes, a supernova could theoretically affect Earth, but the chances are astronomically small. It's akin to winning the lottery, but instead of a jackpot, you get a cosmic catastrophe. The universe is a fascinating place filled with wonders and threats alike. But as we continue to explore and understand it, we can better appreciate its beauty and prepare for its challenges. So, while a supernova could theoretically affect Earth, it's not something you need to lose sleep over. The legacy of a supernova is written in the stars, literally. Now let's take a moment to reflect on the legacy of these celestial powerhouses. Supernovas, in their explosive grandeur, are not just the end of a star's life. They're also the beginning of something new. They're like cosmic phoenixes rebirthing themselves from their own ashes. As a star goes supernova, it blasts out an enormous cloud of dust and gas, a nebula. This nebula contains a rich mix of elements, many of which were actually forged in the heart of the dying star. This includes elements like carbon and oxygen, the very building blocks of life as we know it. Now here's where it gets even more fascinating. Over time, under the influence of gravity, these nebulae can begin to collapse in on themselves. The densest parts of the cloud pull in more and more matter, growing ever larger, ever hotter. And guess what happens next? A new star is born, a stellar baby, if you will, cradled in the remnants of its supernova progenitor. But it doesn't stop there. The leftover material, the stuff that didn't get sucked into the newborn star, can begin to form a disk around the star. And within that disk, tiny particles start to stick together, forming larger and larger clumps. These clumps grow into planetesimals, and eventually, if conditions are right, into fully fledged planets. So, you see, the legacy of a supernova is far-reaching. It's not just a spectacular light show, but a cosmic recycling program on an unimaginable scale. The death of one star gives rise to new stars and possibly even new worlds. So next time you gaze up at the night sky, remember this. Every star you see, every planet, every speck of dust floating in space owes its existence to the life and death of stars long gone. From the ashes of a supernova, new stars and possibly even new worlds can form. Supernovas are not just spectacular events, they're also one of the universe's greatest mysteries. Their immense power, the ripples they send across the cosmos, and the celestial matter they birth. Everything about them is a riddle wrapped in an enigma. In the quest to decipher these cosmic enigmas, scientists across the globe are relentlessly pursuing innovative research. They're probing the depths of the universe, peering into the heart of galaxies, hoping to predict when and where the next supernova might occur. The idea is to understand the life cycle of stars better and identify the telltale signs that precede a supernova. But as you can imagine, it's like finding a needle in an astronomical haystack. Another intriguing aspect of supernova research is the hunt for supernova remnants in our very own galaxy, the Milky Way. These are the ghostly echoes of past stellar explosions, evidence that our cosmic neighborhood has witnessed these cataclysmic events. What's fascinating is that these remnants provide a wealth of information. They can tell us about the type of star that exploded, the nature of the supernova, and even give us clues about the raw materials that went into the formation of our solar system. But the road to these discoveries is paved with challenges. Space is vast, and supernovas, while powerful, are fleeting. Their remnants can be elusive, hidden behind dust clouds, or too faint to detect. And yet, the pursuit continues, fueled by the same human curiosity that once made us look up at the stars and wonder. As we probe deeper into the cosmos, every discovery, every piece of the puzzle we find, brings us a step closer to understanding the grand tapestry of the universe. The study of supernovas is no different. It's a journey into the unknown, a quest to unravel the secrets of the universe. And as we venture further, we can only marvel at the mysteries that await us. The study of supernovas is a journey into the unknown, a quest to unravel the secrets of the universe. So, we've journeyed through the life and death of a star to the explosive spectacle of a supernova. Together, we've witnessed the unimaginable power of these celestial phenomena, the grandeur of their birth, and the profound impact they have on our universe. Let's take a moment to reflect on the key points we've covered in this cosmic odyssey. Supernovas, as we've learned, are not just spectacular celestial fireworks. They are the dramatic death throes of stars, resulting from either a sudden gravitational collapse or a nuclear explosion. The energy they release is so immense it's beyond our earthly comprehension. To put it into perspective, a single supernova can outshine an entire galaxy for weeks or even months. Their birth, as we've seen, is a process of cosmic recycling. Stars, much like us, have life cycles. They're born, they live, and eventually they die. But their death is not an ending. It's a transformation. It's a metamorphosis that gives rise to new stars, new planets, and even the elements that make up our own bodies. We've also delved into the impact of supernovas, a topic that's as fascinating as it is complex. These mighty explosions are not just visually stunning, they're also incredibly influential. The shockwaves they generate can trigger the birth of new stars. The heavy elements they spew out enrich the interstellar medium, providing the raw material for future generations of stars and planets. Their legacy, as we've discovered, is written across the cosmos and within us. The iron in our blood, the calcium in our bones, the oxygen we breathe, all were forged in the fiery furnace of a supernova. We are, quite literally, stardust. But supernovas are more than just celestial factories. They are cosmic beacons that shed light on the universe's deepest mysteries. They've helped us measure the universe's size and its expansion rate. They've given us insights into the nature of matter, energy, and the fundamental forces that govern our reality. In the grand cosmic drama, supernovas are the stars of the show, lighting up the universe with their spectacular finale. They remind us of the cyclical nature of existence, of birth, death, and rebirth. They underscore the interconnectedness of all things, the intricate weave of the cosmic tapestry. And most importantly, they remind us of our place in this vast, awe-inspiring universe. We are but tiny specks in an endless cosmos, yet we are made of the same stuff as stars. We are part of this grand cosmic journey, witnesses to the universe's most spectacular phenomena. In the grand cosmic drama, supernovas are the stars of the show, lighting up the universe with their spectacular finale.